Hi again. More transformation stuff to talk about today. Today we're talking about rotations, and this is coming from section 9.3. All right. I think, rotations are pretty self-explanatory. You're rotating something, so you're just kind of like spinning it. If I was in person, if we were actually in class right now, you would see me doing like this a lot, because you're just spinning something, you're turning something, turning your figure around a fixed point, which is called the center of rotation. So I pulled this from the internet. If we have triangle OAB, starting down here, rotating it a certain amount this way would get you triangle. This should also have like a little prime next to it, since this is your image figure, O prime, A prime, B prime. So you're just kind of turning it a little bit. And this point right here, the actual point O, is the center of rotation. You're spinning this figure around that fixed point. It's not always going to be that you're spinning the figure around one of the vertices of your figure. Actually, most of the time, it's not going to be that way. Your center of rotation will be somewhere further out here in space, and your figure, I don't know, my hands look really big, but your figure would just kind of be spinning around. This is a horrible way of thinking about it. But if your point of center of rotation was out here, your figure would just kind of be spinning around it on the outside, sort of. I don't know if this is making any sense. I hope it will once we actually get into some problems. And is there anything else I wanted to say about this? I don't think so. Actually, probably the only other thing I should mention is that when you rotate, you're rotating it a certain amount of degrees. I don't know if there are like athletes in here. They might do this kind of thing with like figure skating or something like that, where you do like a full 360-degree turn is like all the way around. A full 180 is halfway around. Stuff like that. That's how we talk about rotations, around a certain point and a certain amount of degrees around said point. Okay? So the kinds of basic questions that we've been starting out with is just like, which of the following transformations appear to be rotations? There may be more than one correct answer. Again, I apologize if you can't really read this. Hopefully it'll be a lot clearer in the digital copies that go up on Classroom. So we're looking for some figures that look like they're kind of spun around a fixed point. Part A, kind of like the first one that we saw yesterday, looks like it's flipped over if we're going between the blue and the red. So that's an example of a reflection, so it's not going to be A. B kind of does look like it's going to be a rotation. If we start out from the blue, it kind of looks like it's going around this way. Like your point of rotation or your center of rotation is probably going to be right there. So B probably will be a rotation. C, your figure is oriented the exact same way. That's another thing that I hadn't mentioned about rotations, is that same kind of thing as with everything else. Your figure is the exact same shape, the exact same size. It's just oriented a little bit differently. For example C, it's oriented between the blue and the red exactly the same way. It just kind of looks like it's been shifted down and to the right, which would then be a translation. So that's not going to be it. And then same kind of thing with D that you saw with example B. Going from blue to red kind of looks like it's just spinning a little bit this way, where again, your center of rotation would be down here where those two vertices touch. So D will probably also be a rotation. Okay? I think we talked a lot about what's here. Let me see. A rotation about a fixed point called the center of rotation. We got that. Through an angle of some degree measure is a function that maps a point to its image such that if the point is the center of rotation, then the image and the pre-image are the same point. So we saw that in like these examples, right? If this is your center of rotation, when you spin the entire figure around that center of rotation, this actual point is not moving. you know? So that's what that first bullet point here is saying. If the point is not the center of rotation, then the image and pre-image are the same distance from the center of rotation, and the measure of the angle of rotation formed by the pre-image, center of rotation, and image points is x. All right, so it kind of looks like it's similar to what we've been talking about, all right? If you have A versus A prime, both of these points, your pre-image and your image point, are going to be exactly the same distance away from your center of rotation. And if you have, like, the angle, when we talked about this in, like, way at the beginning of the year in chapter 1, an angle, you need 3 points to form an angle. So all of this that they're just listing out is the 3 points that you would need to make this angle, all right? The pre-image point, the center of rotation, and the image point, if you actually, you're able to construct an angle between those 3 points. And that angle, or the measure of that angle, is your angle of rotation. All right? That's all this is really saying. All right? As we saw with reflections and translations, we're going to focus more on what it looks like in the coordinate plane rather than actually, like, drawing figures using a compass, a ruler, a straight edge. Again, you don't need any of those things. So this is I just skipped right to it. This is really the meat of it. All right. We're talking about 3 different types of rotations, I guess. 3 different general possibilities for angles of rotation. So we've got a 90-degree rotation, a 180-degree rotation, and a 270-degree rotation. And all of these go in the counterclockwise direction. Okay? Which is, if you have like a clock, counterclockwise is going this way. All right? 270 degrees counterclockwise, you also might see that as 90 degrees clockwise. Because if you think about it, right, I'm going to try to do this the best I can with the pen. If you start here, right, we said clockwise is going this way. So 270 degrees counterclockwise would be 90, 180, 270. You'd end up here. So you'd end up facing this way. Okay? If I went back to my original setup and I went 90 degrees counterclockwise, which is this way, oops, I would end up in exactly the same place that I did when I went 270 degrees counterclockwise in the other direction. All right, so the rule for 270 degrees counterclockwise is going to put you in exactly the same place as it would if you went 90 degrees clockwise. So you just have to be careful of that. All right, and then same thing up here. 90 degrees counterclockwise, you might also see it. I think this is a little bit rarer. 270 degrees clockwise should put you in the exact same place. Again, if I started up here, right, and I went 90 degrees counterclockwise, that would put me about there. Going back up to the top, if I went clockwise, 90, 180, 270, again, my Sharpie is oriented in exactly the same way that it was when I went 90 degrees counterclockwise. So again, these phrases are interchangeable for this rule, and these phrases are interchangeable for this rule. So in layman's terms, what does this actually mean? All right, well, and also 180. 180 counterclockwise versus 180 clockwise is going to put you in exactly the same place. So 180 is going to be 180 no matter what. Again, what are these rules actually saying? Okay? If you have your original ordered pairs, if you're going 90 degrees counterclockwise, you're going to switch the places of the x and the y and make your original y negative. All right? This ordered pair talks about like the original y value and the original x value of this point. All right, so you're going to switch them and make your original y value negative, which is now your x value. So this first one is going to be negative. All right. For 180 degrees, you're going to keep the exact order of the points and just make both signs negative. And then for 270 counterclockwise or 90 degrees clockwise, you're going to kind of do the opposite of what you did for up here. You're still going to switch the places of the y and the x, but you're going to make your original x value negative. All right, so y comma negative x for 270 counterclockwise, negative y comma x for 90 counterclockwise, and then 180 is going to be negative x, negative y. You know how, like I was saying yesterday, I think translations are the easiest. I do think rotations are the hardest because these are pretty complex. They're really, really easy to mix up. So I'm actually going to leave this off to the side so I can easily get it for reference as we do the couple of examples that are here. So it doesn't bleed through the page like it has been the past couple days. All right. Rotate triangle JKL with those vertices by 270 degrees counterclockwise about the origin. That's the other thing. All of these are rotating about the origin. And I really don't think we're going to talk about anything that's not rotating about the origin, right? So, same thing that we've been doing. Let's at least graph this, all of this first. Okay, well, this is a very thin triangle. Okay. Again, we're not artists here. Pretend that's an actual nice looking triangle. All right, so we want to rotate this 270 degrees counterclockwise about the origin. So of that here, that's this last rule. All right, 270 degrees counterclockwise, we're going to take all our coordinates, switch the places of the x and the y, and make your original x value negative. So I'm actually going to write that down just so I remember it. And then we can actually apply it using all of these points. So if j is 2, 2, well, that makes j prime very easy because 2, 2, you switch it, still going to be 2, 2, but it's 2, negative 2 because that second point has to be negative because 2 was our original x value. All right, k prime, we're going to switch them, so negative 5, 4, and since 4 was our original x value, we're going to make it negative. So k prime is negative 5, negative 4. And L prime, same thing. Switch them, and since negative 1 was our original x value, we're going to make it negative. So negative, negative 1 is a positive. So this L prime is going to be 6, 1. Okay? Now, I'm going to get my blue pen so I can graph all this in a different color just so it's a little easier to make sense of. All right, so 2. And don't forget when you're graphing these to signify your J prime, K prime, L prime, all of your image points. Okay. Still not the greatest looking triangle in the world, but it sort of looks like we spun it again, 270 degrees counterclockwise and 90 degrees clockwise put you in the exact same place. So 90 degrees clockwise versus 270 degrees counterclockwise look like they're both going to get you something that looks like this. All right? So we'll do another one. I think there's one of each here. Okay. Rotate triangle ABC with vertices that 90 degrees counterclockwise about the origin. So let's, again, graph this first thing. Okay. If I go back to the rules, this is the 90 degrees counterclockwise that we're asked for. So we're going to take our x and y, switch their places, and then make the original y value negative. So again, I'm going to write that down just to remember it. And let's actually do it. If this is our original a, we want to switch their places and make the original y value negative. So this is going to be 1, 2. All right, switch them, make this negative. B prime then is going to be, you would switch these first, or you would switch them, so 1, 4, and then your original y value is 1. So B prime is going to be negative 1, 4. And then C is 3, 3, so that, again, super easy for C prime, negative 3, 3. All right, if we actually graphed it, same kind of thing. It sort of looks like it spun 90 degrees this way, which is counterclockwise. All right. And then rotate ABC by 180 degrees about the origin. Use the same vertices from the previous example. So I have it right here. Our original A was 2, -1. B was 4, 1. And C was 3, 3. So if I plot those again real quick. I think the 180 rule is the easiest of the three because you're just leaving X and Y where they are and just switching the signs for both of them. All right. So if these were your original ordered pairs, A prime is going to be -2, 1. B prime is going to be -4, -1. And C prime is going to be -3, -3. Okay. So same thing, you know, it doesn't look like it's a perfect reflection because it's more so down here than just a complete mirror image of itself over this y-axis. It kind of looks like it was just swung around a little bit and now it's down here. All right. I think part of the reason why this might also be pretty difficult is because now that we're doing all of this with like reflections and we have a whole bunch of transformations that we talked about, you know, so thinking about this at the same time, we would be thinking about reflections and translations. Translations, not so much, but reflections and rotations, like the rules are so similar with the negative signs and when to switch versus when not to switch. I think it can get really confusing for a lot of people really, really quickly. So definitely continue to reach out if you guys have any questions. You guys have been doing a really good job of that so far, and I hope you guys are continuing to stay safe, stay healthy out there, and I'll talk to you guys soon.